Let's learn about geometric sequences. In this video, I'll show you how to find the common ratio, and then once you have it, how to find any missing term either by multiplying or by using the explicit formula. Now, a geometric sequence is just a list of numbers where each term is found by multiplying the previous term by some constant value. We call that constant value the common ratio. In the example above, you see that the common ratio there is 2 because we're multiplying every term by 2 to find out what the next number in that sequence is going to be. Now, if you're not given the common ratio, it's very easy to find. You take any term and divide it by the term that came before it. So, for example, if I wanted to look at the third term in this sequence, which is 12, I would divide it by the second term, which is 6. 12 divided by 6 gives me 2 as the common ratio. I can do this with any two consecutive or back-to-back terms. So if I wanted to look at the term 24, I would divide it by the term that came before it, which is 12, and I would still get 2 as my common ratio. Again, if I did 48 divided by the term before it, which is 24, I would still get 2 as my common ratio. All right, now let's talk about how to find the nth term, so any term in a geometric sequence. In this particular problem, it's asking us to find the 8th term of this sequence, which is the same one that I gave you earlier. Now, I am going to show you how to use this explicit formula that I'm circling in yellow, but first I'm going to show you how to do this by just simply multiplying. So in this sequence, remember that our common ratio was 2, as is shown right here, which meant that we were just multiplying every term by 2 to find out what the next term was. The first term in this sequence, which is denoted by this symbol right here, a sub 1, is 3. The last term that they give us is the 5th term, which is right here. 48 is the 5th term. So now what we want to do is find out what the 6th term is, 7th term is, and finally we'll get to the 8th term. And we can do this really easy by simply continuing to use that common ratio. So if I multiply the 5th term by 2, continuing that pattern, I'm going to get 48 times 2 is 96. So 96 is the 6th term of this sequence. And now I'm just going to continue that pattern. So now I'm going to multiply the 6th term by 2 to get me the 7th term. And I'll get 192 for my 7th term. And you can see that if I multiply just one more time by that common ratio of 2, that I will find out that my 8th term in this sequence is 384. Now let's use this formula up here because there's always more than one way to do things in math, and this formula will be more efficient sometimes depending on what term you're looking for. So to use the formula, like all formulas, we just have to substitute in the values that we have. So a sub n is the term that we're looking for. We're looking for the 8th term. We don't know it, so I'm just going to rewrite that as a sub 8. They're asking us for the 8th term is equal to. Now a sub 1 indicates the first term. You'll see that I also have it here in orange. So my first term is 3, so that'll go there. And that's being multiplied by r, which denotes the common ratio. And again, if you just see the blue up here and the blue over here, the common ratio in this problem was 2. And that's going to be raised to the n minus 1 power. Now notice that this n and this n are the same. So what n are we looking for? We're looking for the 8th term. So it's going to be to the 8 minus 1 power. Now let's just start simplifying this. So we have the 8th term will be equal to 3 times 2 to the 7th power. Don't forget to follow order of operations in this, right? We're not going to multiply and get 6 to the 7th power. We're doing exponents first. So now we're doing 2 to the 7th power, which is going to give me 128. And now we can multiply, and it'll give me that the 8th term in this sequence is 384, which is exactly what we got when we just kept multiplying the common ratio.